Hi, so today I'm going to be going over a quick review of how to graph a polynomial. First, we're going to apply the leading coefficient test, and we're going to list the possible zeros, and then we're going to use synthetic division to see if we can come up with all the zeros that we need. So first, we have to look at the leading coefficient, which in this case is negative. So we have a leading coefficient that's negative, and its exponent, as long as it's written in standard form, is even. So it's 4, so it's even. So I have a negative, even leading coefficient. Leading coefficient test would then tell me that this polynomial is down, down. Its end behavior is down, down. So it's going to be doing this on one end, and it's going to be doing this on the other end. All right, so then I need to list the possible zeros, okay? All right, so your teacher might have talked about using the coefficient of the first term and the last term. We call the last term P, the first term Q. So first we want to list out all the factors of P. So that would be 1, 2, 4, and 8. Okay? And then we want to list all the factors of Q, which would be 1 and 2. All right, then we put each P over its Q, and we do a plus minus version. So my zeros, my possible zeros would be 1 over 1, 2 over 1, 4 over 1, 8 over 1. So in that case, it would be 1, 2, 4, and 8. And each one of them would have a plus and minus. That could be a possible zero. Okay, then I move on, and I do the next set. So 1 over 2, 2 over 2, 4 over 2, and 8 over 2. Okay, so that adds to us 1/2, plus or minus 1/2, because 2 over 2 is 1, which we already have. 4 over 2 is 2, which we already have, and 8 over 2 is 4, which we already have. So these are all my possible zeros. All right, so now you can start testing them. So what do you mean test them? Test them by using synthetic division to see if we get a zero. So I'm going to use synthetic division. So I'm going to use the root of 1. Okay, so I'm going to start there. And again, my polynomial was 2x to the fourth, negative 2x to the fourth, plus 13x cubed minus 21x squared plus 2x plus 8. And one thing that's kind of helpful for me too, and I forgot to mention it, is that leading coefficient of 4, it means that it's going to have actually 3 turns to the graph. To find the amount of turns, you take the highest exponent and just subtract 1 from it. So I know that this graph is actually going to turn 3 times before it has this end behavior of down, down. All right, so let's get back to, I'm going to test 1. Now, remember with synthetic division, we take the coefficients of each term. So negative 21, 2, and 8. And then we bring down negative 2. And we multiply 1 by negative 2, which is going to give me negative 2. And then I add down, so that's going to give me 11. 1 times 11 is 11. So I'm going to put 11 here. And I'm going to add down, that's going to give me negative 10. 1 times negative 10 is negative 10. Negative 10 plus 2 gives me negative 8. Negative 8 times 1 is negative 8, and we add down and we get 0. So that tells me, because I got a remainder here of 0, that 1 is a factor. So that's great. That means a root. So 1 is a root. So that's awesome. We've got one of our roots. Now that doesn't always happen. So there's a couple things that you could do. You could use your calculator. So I took the opportunity, I did it 2 ways. I first graphed it on Desmos, and you can see that this graph opens down, down. And if I zoom in just a little bit, oops, wrong way, you can see there's those 3 turns we were talking about, 1, 2, 3, okay? But there's one of my zeros. So you could graph this, and then you can see that 2 is another 0. So then you could jump back to trying the number 2. But I'm going to try it on this new revised polynomial I have. So I'm going to do 2. And actually, let me do it up here so it's a little bit easier. Move that up. So I'm going to bring negative 2 down. Let me extend my page. So 2 goes times negative 2 is negative 4. 11 minus 4 is 7. 7 times 2 is 14. Negative 10 plus 14 is 4. 2 times 4 is 8. So there, we proved our other 0. Now at this point, I actually always like to check to see if what I'm left with is factorable to get the other zeros. So for example, this polynomial, if I got that first 0 and I wanted to write it as a polynomial to see it was factored, I would go down 1 degree from the original. So this would be negative 2x cubed plus 11x squared minus 10x minus 8. And I could see if that was factorable. It doesn't appear to be, but now I'm going to check on the second 0 that I got. That would give me negative 2x squared plus 7x plus 4. Okay, so I'm going to see if that's factorable, but first I'm going to pull out a negative 1, and that's going to give me, and I'll set it equal to 0, that's going to give me 2x squared minus 7x minus 4 equals 0. And let's see if this is factorable. So we got a 2x and an x, and a 4 and a 1. That's going to give me an outer term of 8 and an inner term of 1, so that actually works. And I can set each factor equal to 0, so 2x plus 1 equals 0, so x equals negative 1/2, and x minus 4 equals 0, so x equals 4. All right, so that means that I've got zeros of 1, 2, negative 1/2, and 4. Those are my zeros. Now, I know that I have 4 of them. I know I'm done because the highest exponent is a 4, so the fundamental theorem of algebra says that it could have at most 4 zeros. All right, so I'm going to go to a graph. I'm going to make a graph here. And I think I had negative 1/2. Let's just check. Negative 1/2, 1, 2, and 4. Okay. Negative 1/2, that would be right about here. 1, 2, and 4. Those are my zeros. Let me put those in red. And we know that the graph opens down, down, and we know that it's going to have 3 turns. I also like to have that y-intercept if it's a reasonable y-intercept, and the y-intercept is 0, 8. So I'm actually going to put that on my graph as well. Let me get there. And 1, 2, 3, 4, 5, 6, 7, 8. And I'll put a red dot there as well. Okay, so I'm going to try and graph my polynomial. So I'm going to go up to the y-intercept. I'm going to turn around again, and then turn around again. Now, I don't actually know these points right here, but for now, that's a really fine way to graph my polynomial. I know it has to have 3 turns. I've got all my zeros, and I know that my end behavior is down, down. All right, guys, hopefully that was a helpful video on how to graph a polynomial using the leading coefficient test and synthetic division. Have a great day.